Our first idea for the project was to create a lens out of ice by freezing water inside half of a tennis ball, and then use the ice lens to create magnified images. We cut tennis balls in half, put butter on the inside so the ice wouldn't stick, filled the halves with water, and then froze them. Unfortunately, the ice would not freeze evenly. Freeze it too long, and it would become clouded, but freeze it any less, and the inside would be liquid, making it very fragile. We were only able to use it for a few minutes, and the effect was not that impressive. Still, it was a fun experiment. Our second experiment is where things got aggravating.
Our second experiment involved Jell-O. Alex got a little freaked out when she found out what ingredients are in it. We wanted to see if we could shine a laser through Jell-O, measure the angle of refraction, and then be able to calculate the Jell-O's index of refraction. So first we made the Jell-O based off of the instructions on the packaging. We made red, green, and orange Jell-O. We made different colors because we wanted to know if there could be different indexes of refraction for different colors of Jell-O.
After the Jell-O set, we put them on plates and attempted to cut them into concave and convex lenses. Our cut did not turn out very well, and some of the Jell-O was too thin to shine a laser through properly. After hours of work for the day, we decided to call it quits and resume another day.
The next time we met, we created more sophisticated molds for the Jell-O, using blender containers for the convex lenses and tiny condiment bottles in the middle of Tupperware to create the concave lenses. The convex lenses were easy enough to remove, but the concave lenses were a bit more challenging.
Here, ready for this? Here. No!
When you get what you want, not what you need. When you feel so tired but you can't sleep, stuck in reverse.
But ultimately, we were able to end up with one good convex lens. Unfortunately, the red laser did not shine through the orange convex lens, so we could not measure the angle of refraction. The only Jell-O we could see an actual light beam through was the red convex Jell-O, but it was very dim and we couldn't see the entry or exit beam, and were thus unable to calculate the angle of refraction as well.
Our last idea was that we could use a stronger and brighter laser to be able to see the entry and exit rays as well as the ray through the Jell-O, which would allow us to measure the index of refraction. Unfortunately, the green light bounced right off of both red and orange convex Jell-Os, almost like the Jell-O was a mirror. Our question to you, the viewer, is, why would this happen? Please leave a comment down below if you can help explain. So, this was all the experimenting we had time to do. We weren't able to do what we originally had planned, but we did a lot of trial and error and gained a lot of experience. Thanks for watching.
When you try your best but you don't succeed, when you get what you want but not what you need, when you feel so tired but you can't sleep.